Hello everyone, I hope you all are doing great. So today we'll be starting a new lecture on AC current. What is AC current? So before delving into the introduction of AC current or its definition and all, you must know that first of all, what is current? So if we talk about the basic definition of what is current, so current is basically the flow of electrons. It's flow of electrons. It's usually denoted by a symbol that is I, and I is always equal to the change in charges Q divided by change in time. So with respect to time, how much the flow of electron changes, it's called the current. So this is the basic definition of the current. Now there are basic two types of current in this world. First one is known as a DC current, and second one is called AC current that we're gonna study in this whole lecture. But first of all, you must know that what is a DC current. So DC current's full form is direct current. Now, by the word direct current, you might get some sort of idea that what does it mean by the direct current. So basically, whensoever an electron is placed here, and let's say this is a electron, and now a electron is connected with a positive terminal. This is the positive terminal, okay, in this case, and this is the negative terminal, and a electron is at this direction. So what will happen? Basically, the electron will get attracted towards the positive terminal. This is something really common. But what if I say that on the same time when electron was moving in this direction, when it reached out this point, let's say it wasn't so close to the positive terminal, but when it reached this point, suddenly there got a change in the polarity, and this become negative terminal, this become positive terminal. So in that case, what will electron do? Electron will again change its direction and it will start moving in this direction. Initially it was moving in this direction, but due to polarity change it starts moving in this direction. I think till now this thing is clear to you that this is all about movement of electron. Now whensoever you're talking about a cell or a battery, so in that case, we know this fact that we have a specific negative and positive terminal of a cell or a battery. But whensoever we talk about a current that we are getting from appliances, or we could say things like transformer, so we cannot say that the current coming from the transformer have a same thing like something like battery, that okay electrons will move in this direction. That's not the case. If that's the case that electrons are moving in this direction, so in that case people won't get any sort of electric shock, because electrons are moving in the same direction. So why would they get attracted towards your body and you get an electric shock? So this is the place where the concept of the um, directional current comes. Current that is having more than one direction. Electrons that are moving in one direction, those electrons are known as DC current, direct current. But in case of AC current, the electrons that are moving in two directions, you could say direction. So that case, those sort of electrons are known as AC current, alternating current. I think I forgot to tell you about its full form. Well, its full form is a alternating current. Alternating current. Okay. Okay, I hope that so far things are clear to you. The concept of the AC and DC is clear. Now let's again get to the point where we were studying about the AC current. Let's get back to that. Let's just remove this place and so we will get some more space to uh, think about this place. Okay, I think we are going to start. So, first of all, the basic properties of AC current. Now, basically, whensoever we are talking about the AC current, so AC currents are mostly used in generators. Generators are those devices that uses the electrical energy to convert it to the mechanical energy. Those devices are known as generators. So the AC currents are mostly used in the generators. First thing, this is the property of the AC current. Second thing, AC currents are mostly have sinusoidal wave. I think I should use this word, sinusoidal wave. I think you are pretty introduced to trigonometry, in which we do have two types of functions. First is called sine, second is called cos. So the function of the AC current is just like sine waves, and sine waves we know that lies between +1 to -1. We do consider this fact that it lies in +1 to -1. So this is also a thing. We're going to study this fact in detail. Okay, now one property that makes AC current an AC current is that, let me, just a minute. Okay, I'm back. That it changes its polarity. Now, what is polarity? Do you know about what is charge? The polarity is basically the charge. When a wave change its charge just by changing the node, this is called the AC current. Now let's consider this wave. Okay, now this is a wave. If we consider this wave from this point, so it is positive. From this point it's positive, from this point it's positive. Throughout the whole wave it is what? It is positive. That means throughout the whole wave or throughout the whole cycle, this kept positive. So these sort of waves are called DC waves. But in the case of the AC waves are not as it is throughout the whole cycle. AC waves have polarity change. Like if you consider it's one cycle, so there will be different polarity. Like in this region it is positive, but if you consider this region, so it becomes negative. And this makes the calculation of the AC currents way more difficult because you cannot instantaneously tell the value of the AC current or its maximum peak value at any case. So this is the basic things about AC current. Now let's talk about some of the terminologies that we'll throw out use in the whole journey. So first term is that what is a cycle? Well, don't consider it a cycle that you used to ride when you were a kid. Well, it's a different cycle. It's in the case of the waves. So cycle is basically measurement of one positive node. This is called a node. From this point to this point, this is called a node. So one positive node and one negative node. This is called one cycle. Measurement of one complete cycle is equal to one positive node and one negative node. Okay, this is the basic definition of a cycle. Second terminology is time period. Time period. We'll use this word throughout our whole journey. Time period. Now, time period is basically the calculation of the time or I could write it here, time taken by one cycle. Like from this point to this point, how much time was taken, and to complete one cycle, this is called the time period. And one more important point, that time period always have a reverse relation with frequency. Now what is frequency? Just opposite the time period. Frequency is actually the measurement of the wave that was counted within 1 second. Or let's write its definition here. What is frequency? So it's actually the wave within 1 second. So this is called the frequency of that thing. And frequency is again, its frequency is in inverse of wavelength. If you have studied the chapter wavelength, so in the case of this wave, the frequency is higher. Like from this point to this point, just consider it's 1 second, so this is a high frequency. But in the case of this wave, this is of long wavelength, because wavelength is measurement of crust and trough. So it is long wavelength but a small frequency. Since it will consider it its frequency, so it will be something like this. So these are the basic terminologies. Moreover, we do have one more important terminology. Let's just first erase this whole mess, so we could reconsider writing. We'll get some space to write that thing. So one important terminology that I think you must know is that, let's consider this is a wave. In this wave, this is what, this is the starting point. Okay, starting. This is the measurement of one cycle. Now the maximum amplitude, or you could say the maximum point of one polarity, this point, let's say, and here this point, let's say, this is called the peak value of that wave. Peak value. In the case of the DC current, all the peak values are of one polarity. But in the case of the AC current, the polarity of the peak values change. And if we consider, okay, this point is what? Now tell me, is that a peak value or not? Is that a P or not? So to tell this instant, the value of the current at a specific instant point, instantly, this is called what? Instantaneous peak value. Instantaneous peak value. So this was the term that I thought you must know. Okay, in the starting, as I stated, that AC current has some, we get some difficulty to measure the AC current just because of its change in polarity. So because of this change in polarity, we always get difficulty in measuring the instantaneous peak value, the value of the current at any instant point. So to handle that situation, to handle this fact, we get introduced to another thing. Or let's say, what we usually do, if a person walks from this point to this point, and then he walks from this point to this point, and this point to this point, and then this point to this point, and this point to this point. So what would I say? That what that person, like in combinedly, like collectively, how much he actually walk. So what do you usually do? We take average of that value. Average. Let's say from this point to this point, he walk 20 centimeters. From this point to this point, he walk 10 centimeters. From this point to again this point, I'm just taking some instant values. Don't consider the actual values. Let's say it's 20 meters. So in that case, what we'll do, we'll divide it with by 3 because we have three values, and our answer would be something like 50 divided by 3, and you can just calculate it since it's not our topic. So I'm just telling you that thing that whensoever it becomes difficult for you to tell an instant and direct value, so you take the average. Same things and same phenomena we apply for the case of AC current as well. What we usually do, we usually take the average, and that average is equal to 70% of the peak value. If the peak value here is let's say 90, so we'll take 70% of the value 19. Let's say 90 ampere. So we'll take the 70% of the 90. That will become the RMS value, root mean square value. How to take the root mean square value? That is also simple. First, you need to square the value. Square the value. Let's say it's okay, 90 will be a larger number. Let's say it's 2. So how to take out the root mean square value? First we'll square the 2. So 2 square is equal to 4. Then what we'll do now, as the second point, we'll take its mean. Mean is another term for the middle value, or for the average. So here we have only one value, so we'll divide it by 1, so it will become 1. Oh, sorry, 2. So this was the mean. Then third would be its root. We'll take root. Okay, it will be 4. Sorry for the inconvenience. It will be 4. So now you'll take its root. So 4 root is equal to 2. So this would be the final answer. That's how you take the root mean square value. I hope that you get it, and thank you so much for watching. Stay tuned for future videos.